Hi everyone, this is your 1.5 practice that I'm going to go through for your little answer key here. So first thing, it lists the definition. An argument consists of premise or premises and one conclusion. We're going to determine the validity of an argument. An argument is valid if the conclusion is guaranteed under the set of premises. So we want to see all true in our truth columns. That's what we're doing now. So we have the statement, if it is Tuesday, then the tour group is in Belgium. The tour group is not in Belgium, so these two are the premises. And then our conclusion is, therefore, it is not Tuesday. So let's define part A, P and Q. What are the parts that make up this statement? I'm going to call P the statement, it is Tuesday. You want to keep everything in the positive context, even though it says it is not Tuesday. And at one point, we can just negate this later. And I'm going to call Q, the tour group is in Belgium. Okay, so that means that this statement up here, this first one would be P, if it is Tuesday, then the tour group is in Belgium, so P implies Q. The tour group is not in Belgium, so that is not Q. Therefore, it is not Tuesday, so that is not P. So here I go, I have P, Q. I have a not P in there. Not Q. I'll maybe put this in a bad order, but that's okay. We'll make the best of it. P implies Q. So I'm going to label this. This is 1. This is 2. This is my conclusion. Sorry, I put that in a silly order, but we'll be able to make do. So we want to show the conjunction of 1 and 2. Oops, parenthesis there. And then our final step will be the conjunction 1 and 2 is conditional with the conclusion, so not P. All right, so here we go. For P, I have 2 possibilities, so there's 4 rows I can make here. All right, and then I alternate Q. That's just the general setup. Then I have not P, so that's the opposite of this row of P, so that's false, false, true, and true to negate that. Opposite of Q is going to be the opposite of this row, so false, true, false, true. P implies Q, so this is true every time except if we go T to F. So here we go TT, that's true. TF is false. FT, that's true. FF, that's true. Just a rule for conditionals there. 1 and 2. So I need both of these to be true to get a true in this column, the conjunction. So 1 and 2, this is false. 1 and 2, that's false. 1 and 2, that's false. True, true, this one's true. So then I want the conditional of this row to see this row. So again, this row, if this row is ever true and then false, that's where I get the false for a conditional. So here I go F to F, so that works. Okay, it's not TF, so that's fine. This one is F to F again, so that's true. This one's F to T, so we're still okay, that's true. And the last one's true to true, so that's true. So this is a valid argument. Valid, because the whole last row is true. Bam. Draw a Venn diagram to support our claim. So we're going to go all the way back to the beginning of this section. So if it is Tuesday, then the tour group is in Belgium. So basically that's like on all Tuesdays. The tour group's in Belgium. Okay, so we can fill in that. But then we have the tour group is not in Belgium, so that's over here. Oh. All right, so actually, is that right, or should I switch those? Actually, I think I should switch these labels, you guys, because you could think of a different argument here. So, whoa, this should actually be, I'm rushing because I'm actually going to your class. It's Friday, and I'm about to go to your class right now. Okay, so this would be, instead of Belgium, these are all the Tuesdays. So for every Tuesday, the tour group is in Belgium. All right, so then if we are, sorry, we have the quote, then the tour group is not in Belgium, so that's over here. We cannot overlap, right, the Belgium and Belgium, so this makes it a valid argument. So this is a better picture of that. There you go. Tautologies are arguments that are always true. You want to add this, like a little note here. All right, and then we have one more thing on this next page. Okay, I break this up for you a little bit because I was like, we should add some steps here. So there's A, B, and C that kind of breaks up this process. I'm just going to do those on the fly here. So we say use a truth table to determine the validity of the argument specified. If the argument is valid, interpret the specific circumstances that cause it to be invalid. So here we go. If you watch television, you do not read books. If you read books, you are wise. Therefore, you are not wise if you watch television. So let's, part A is name P, Q, and R, and write the statement that we're looking for here. So I'm going to make P the statement, you watch television. I'm going to make Q the statement, you read books. And I know it says you do not read books, but we want to keep things in the positive context. And then let's make the last one, you are wise. All right, so number one, then, this first statement would be you watch television, so P implies not reading books, which is Q, so not Q. Next one is you read books, so that's Q. If you read books, so that's a conditional if. Then you are wise, that's R. And so then my conclusion, you are not wise, not R, if you watch television. Oh, this is a conditional in the other order. If always comes first, so we can rewrite this last statement as if you watch television, then you are not wise. So if you watch television, that's P, then you are not wise, not R. Okay, so we are going to show this. Part B is like make a truth table. So here we go. We would have P, Q, R. All right, so we've got 3 statements, which means we're going to have 8 rows here. We also have not Q. We have a not R. I'll get those in there. Now I'm going to make each of these parts here. So we've got P implies not Q. We have Q implies R. So that's 1 and 2. And then we can also do the conjunction of 1 and 2. 1 and 2. And then we can do the conclusion, how about, which is, sorry, P implies not R. That's the conjunction, or sorry, the conclusion, I should say, not the conjunction, the conclusion. And so then we want 1 and 2 implies the conclusion. I think that's all we'll need here. All right, so P, we'll set this up. 4 truths, 4 falses. All right, then we have 2 truths, 2 falses, 2 truths, 2 falses, and then we alternate. True, false, true, false, true, false, true, false. There we go. So not Q is going to be the opposite of this row right here. So we're going to go false, false, true, true, false, false, true, true. And then I'm going to go ahead and take care of this row right here just while I've got this. P implies not Q. So this is a conditional. If we go T to F, then it's false. So this one's false. T to F again, this one's false. T to T, that's true. T to T, that's true. F to F is true. F to F is true. And F to T is true. Okay. So then I can do not R, so that's opposite of this row. So F, T, F, T, F, T, F, T. And then Q, so that's this row here, and not R. So, oh, sorry, yeah. Oh, wait, did I need a not R? No, not yet. Sorry, I don't need it yet. This is just Q implies R, so I'm looking at these two rows. So true to true, true. True to false is false. False to true is true. False to false is true. True to true is true. True to false, that's a false. False to true is true. False to false is true. Okay, now we can look at 1 and 2. I'm going to do this in a different color. This is the conjunction of 1 and 2, so we need both to be true to get a true. So this is false, false, true, 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 false, true, true, hooray. Okay, and then here's where we get P implies not R. So I'm looking at these. True to false is false. True to true is true. True to false is false. True to true is true. False to false is true. False to true is true. False to false is true. False to true is true. Okay, last one. We have 1 and 2. So this purple row implies my conclusion, which is this red row right here. And again, we just can't see T then F. So true, true, false, true, 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 true. Bam. So the last part we have an issue with right here, this false. So let's go back. We get these false conditions in the third row, that's right here. So part C is, when is this statement invalid? C. This statement, or actually it's an argument, I should say. This argument is invalid if the person, if you watch TV, so that's television, but you don't do Q, you don't read books, and you are wise. You are wise, right? So that's saying that totally does not make the statement true if you only watch TV and you're still considered wise, right? Because that's like not what the statement was saying at all. So that'd be the only thing that makes this statement false. And that is the end. There you go. I need my mouse. I'm going to see you guys in class in 2 minutes.